All right, we're back at it. Unit 4, Day 3 today. We're going to go a little bit deeper into inequalities. We're going to do some compound inequalities, which means that there's two inequalities at one time, and they're joined together. So that's the beginning here. It says a compound inequality is two inequalities that are joined together. There's two types. The first type is called a union type, or an OR. See how it has the quotation marks around OR? Whenever we see an OR, we know that this type of inequality is going to be shaded away from each other. So there's going to be a gap in between the shading. So if we take a look at this first example, it says x is less than 2. So we know that that was an open circle at 2, and it's shaded to the left because we always go the direction the arrows are pointing. And then the second part of this, it says OR, so that means that it's a union type. And then it says x is greater than or equal to 5, so that means it's a closed circle at 5, and we're shaded to the right. So that is what a union or an OR type of compound inequality looks like. So they're always going to be shaded away from each other. There's going to be a gap in between. For the AND type of inequalities, right here, the word AND, it's going to be the opposite. There's only going to be shading towards each other, and there's going to be nothing going to the far left and nothing going to the far right with an AND. Now, there's two ways that it can be written. It can be written with this word AND very easily, just like this. Or it can be written on this right side like this, where x is in between the two numbers, and the smaller numbers on the left and the bigger numbers on the right, and then you just use the inequalities that they show. But this right here, this one, if you notice, it got flipped because it put the x in the middle. So that means this x is greater than 2 becomes 2 is less than x. So you got to flip the inequality, the x and the 2, if you want to put it in the middle. But those two things are identical to each other. So this whole thing that's circled on the left is identical to the thing that's circled on the right. So if we were to put our circles down, x is greater than 2 is an open circle at 2. Less than or equal to 5 is a closed circle at 5. And then because it has the word AND, I know it's shaded in the middle. Or because the x is in the middle right here, I know that it's shaded in the middle. So if the x is ever in the middle, always shade in the middle. So that's two different ways that you can write an intersection type problem, or an AND is with the word AND, or just putting the variable in the middle and then shading right down the middle of it. So there's no gap in there. So it asks us to graph ANDs and ORs here. So number 1, greater than or equal to 3. We go to 3 and we put our closed circle. We graph greater than or equal to, which means we're shading to the right because greater than is pointing to the right. Less than -5 is an open circle at -5, and less than means you're shading to the left. And that's what that would look like if we just graphed it. This next one, the x is in between, so that means that's where the shading's at. So the 1 has an open circle, the -2 has a closed circle because it has the equal to, and we know we're shading in between. That's an AND type of problem. And the last one is an OR. So less than 0 is an open circle, less than means shaded to the left. And then greater than or equal to 4 is a closed circle at 4, shaded to the right. And that's what it would look like for the third one down. So those are the three for the graphs that we started with here. The next section is a little bit of solving problems now, okay? So if we were to solve, it wants you to get the variable by itself, just like we have been doing with solving. So for number 1, in order to get x by itself, we'd have to subtract that 2. And when we subtract the 2, we have to subtract the 2 for each inequality that we see, because it's all one big compound inequality here. This is a big AND type of inequality. So the 2's cancel out there, and now the x is by itself. And if you were to subtract 2 on the left side, you get a 7. And if you subtract 2 on the right side, you get a 9. So if we were to graph that, we make a 7, we make a 9, and then they're both equal to, so they're both closed circles, so let's close them down. And then it's graphed in the middle because it's an and type problem, because the x is in the middle. Number 2, in order to get x by itself, we'd have to take care of this minus 20 first. So that'd be plus 20 on both sides of the inequality to balance this out. What we do on one side, we got to do on both. So we get 0 is less than 4x, which is less than or equal to 50. You divide by 4. You divide by 4 on all 3 sides because there's 2 inequalities. And now we get 0 still on the left side. 50 divided by 4 in my calculator is 12.5. So now we have 0. We have 12.5 or 12 and a half. The 0 has an open. The 12 and a half has a close because it says equal to. And it's shaded in between again because that's where the x is. It's in between. So that's how you do the hard ones for the and type problems. For number 3, to get x by itself, we'd have to subtract the 4 from all 3 sides. So now we're left with negative 3x is less than 6, which is less than negative 3. We divide by negative 3 to get the x by itself. And whenever we divide by a negative, that flips these signs, right? Remember that rule? Hopefully from a couple days ago. So that means that we're going to have an and as well. And we flipped both those signs. So I know that negative 2 is smaller, so that goes in the left. 1 is the bigger one, goes in the right. They're both open circles according to their inequalities. And because x is in the middle, I know it's shaded in the middle every time. So that's number 3. Number 4 has a word in between. If it has a word, those are the easy ones. It just means you break it up. So you do the whole left side, and then you do the whole right side. So this would be b is greater than 5 if you divide by 3. Then on the right side, we divide by 2, and we get b is less than negative 2. So we go to the number line. We put a negative 2 and a 5 down there. And sorry to bug the squish. These were open circles. And if I do greater than 5, it's to the right of 5. I'm looking at that correctly. And then left of negative 2 because it says less than. And it's an or, so that makes sense because there's a gap always with ors. So that's would be number 4. I see a word, so I just break it up for number 5. So I subtract the 7. I get 2a is greater than 2. You divide 2. You get a is greater than 1, or you divide by negative 4 on both sides. You get a, you got to flip the sign because you divided by a negative. So a is less than negative 2. We got negative 2. We got 1. So greater than is open circle to the right of 1. Less than is an open circle to the left of negative 2. So that's what it would look like there for that one. And this last one also has a word, so I'm going to break it up in the middle. Divide by negative 4 to do the left side. That would flip the inequality because we divided by a negative. This right side, we got to distribute the 2 in. So we get 2d plus 6. We subtract the 6 over. And we get 2d is greater than negative 18. Divide by 2. We get d is greater than negative 9. So now we have our 2 inequalities. So negative 9 is smaller than negative 2, so that goes on the left. This is less than negative 2, so it's shaded to the left. This is greater than negative 9, so it's shaded to the right. And it's an and, so it should be shaded in the middle. So ors are always shaded away from each other with a gap in between. Ands don't have the gap, they're shaded towards each other. And the last 2 are inequalities with words. So we're kind of putting all the days together now. So it says Susie wants to walk between 25 and 30 miles each week. So 25 is my far left. 30 is my far right. I know with the word between, it's an and type problem. So I'm going to put down my less than or equal to signs. And I know my variable is going to be in the middle. So it says she plans to walk the same distance each day, 5 days a week. What's the range of miles she should walk each day? Okay. So if there's 5 days a week, and M for my number of miles, I'll say, because that's what we're looking for. Whatever we're looking for is how many is always going to be our variable. So we're looking for miles. So we divide by 5, divide by 5, divide by 5, and we get between, it looks like 5 and 6 miles. So the range, since it's given to you in words, you should write the answer in words, is between 5 and 6 miles a day. So that would be number 7. And then number 8, it says Carmen sells at least $500, but less than $600 in sporting equipment each week. So far this week, she has sold $395 worth of equipment. How much should she sell the rest of the week to reach her goal? All right, so she needs to sell at least $500. So that means greater than or equal to 500, less than $600. Looks like that so far, right? So far, she has sold 395. So we have x plus 395 for this one. We have x plus 395 for this one. So this one's going to be an OR type problem, I believe. So if we subtract 395 from both, let's see what we get here. We get that she needs to sell greater than 105. I think that's what that is. Yep. And then less than, is that 205? So in the end, that's what we would say. We would say she has to, so was it Carmen? Has to, what is it? Is it sell? Yeah. At least 105 and less than 205. And that is all the notes for today. See you tomorrow. Have a great night. Talk to your teacher if you have some questions.